And we're back. So this time what we're going to do is we're going to talk about the third topic, which is the iDisposable interface, specifically classes that implement it, and the using keyword, which makes life with unmanaged resources much easier. So this is a one paragraph explanation of something that's fairly complicated. And what I'm going to do is I'm going to give a sort of high level overview, and I'm going to give an anecdote that hopefully helps you sort of think about this. So the way that this whole kind of CLR situation works with garbage collection is that C# has two types of resources that it can deal with. Either resources are managed or they are unmanaged. So managed resources get disposed of automatically by the garbage collector using a mark and sweep algorithm. And basically what happens is as soon as a piece of information goes out of scope or becomes inaccessible, that piece of data is marked, and then over a period of time it is flushed out of memory, so you don't have to deal with it hanging out anymore. However, there are also unmanaged resources. So unmanaged resources are typically things like database connections, TCP/IP connections, file streams, all these kind of things that go from your program out to other things and interface with other systems. So the file system, a database, engine, something like that. So these unmanaged resources, they are not handled automatically by the garbage collector. And what that means is you, the programmer, have to dispose of those unmanaged resources manually. And so in order to do that, what happens is these unmanaged resources implement what's called the iDisposable interface. And in the page on Canvas, I've embedded these links that give you a crazy amount of detail about the interface itself, all of the different classes that implement that interface, so you can kind of get an idea of what an unmanaged resource looks like. And then also the specific pattern that you're supposed to implement in order to safely dispose of an unmanaged resource that you are using. So the thing about unmanaged resources is if you have a bunch of unmanaged resources and there is something wrong with your specific implementation of the disposal of that resource, the number one thing that will happen is memory leak. So you will have, I don't know, database connections, or you'll have file streams that are hanging out somewhere, and these things will just build up and build up and build up and build up and build up, and then eventually you'll max out memory, and then you'll have to reboot the machine, and then everything is kind of cool again. So this is a thing that is fairly common in the .NET sort of environment. It's a thing that makes .NET applications kind of get a bad rap, primarily because this specific pattern falls victim to two extremely common things. And so that's what this is saying. There are two really big issues with this. So if you're doing multi-threaded programming, and you are trying to deal with unmanaged resources on background threads, you could run into tons of issues if you are not safely coding those background threads. And that is kind of a non-trivial task, as many of you probably know if you've taken operating systems or something like that. This is not necessarily an ideal situation to deal with. You have to manage all of your own like sort of testing and bugs and all that kind of stuff. It's not great. The second of these is exceptions. So the primary one being null reference exceptions, right? So we have a situation where potentially an exception could cause the rest of your code to not run. And if that code doesn't run and that code contains a critical piece of the disposal implementation, that means that your unmanaged resource is not going to ever be disposed, which ultimately means you're going to have a memory leak. So there is a best practice for 99.9% of the disposable unmanaged resources that use the using keyword to restrict the scope of the unmanaged resource. And what ultimately happens is when this thing falls out of scope, the disposal implementation is automatically called regardless of if an exception happened inside of that scope. So it effectively works exactly like a finally. So if your code runs into an exception, prior to leaving that unit of code or that critical block, it will run the disposal method, which will ensure that there are no memory leaks, even in the event of an exception, or B, even if that exception exists on a background thread. So what we're going to do is we're going to talk about the using syntax, and we're going to talk about unmanaged resources in general by dealing with reading a file. And so this is an extremely common sort of thing that you would want to do in any programming language. So we're going to kind of try to kill two birds with one stone. So what I have here is I have a text file called test.txt. Here is test.txt. This is just some random text that I typed into the text editor here. It has line breaks so that I can show you how line breaks work. And if I make sure that that is saved and then I close that out, what we're doing here is we are setting a path to that file as a string literal. So there's one additional new symbol here. Symbol is the @ symbol. So what this is saying is this is a string literal, and even though this thing has a backward slash or backslash, it is read as a literal backslash, and it does not have to be escaped. So if you don't have that @ symbol, we have a tab character now. That's not necessarily what you want, so you would have to escape that character, or you can just use the @ symbol. So the @ symbol basically just gets rid of interpolation. It gets rid of everything inside of the double quotes and makes this thing a literal. Okay, so we are reading, or not reading, we're setting the file path to this local variable called file path. We're using var, which means that this thing is going to be a string. And then the first way that you can read a file is through what are called, they're static methods. They're static methods on the file class. So file is a member of the system.io namespace. And so we're going to go through assemblies and namespaces next week in a little bit more detail. But as long as you have system.io up here, you can access file. And the first one is read all lines. And so what this does is it takes the file path in, and what it's going to do is it's going to produce an array, a string array, of all of the lines separated by the new line character. And so if I run this up, I get exactly what I expect. So this is the contents of my text file that I was showing you a while ago, and that is really just because I'm iterating through the array and I'm printing each line one at a time. So the other thing to note about this is even though this thing is passing back a string array, and this is a string primitive, we can still do the enumerable list stuff because we have all of the sort of nice .NET helper methods on all of these types. So you can still use for each. You don't necessarily have to use a for just because you're using an array. Groovy. So let's say that you didn't necessarily care about the line breaks, or you were reading a file that was originally created on a different operating system, and so the file or the new line characters are different, or it was created as part of some esoteric database system, and instead of having regular new line characters, it has some crazy new line character made up of God knows what. In that case, what you probably want is just to read in all of the text. So that's what file.readAllText does. So what this is doing is it's taking in the same file path, and now what it's going to do is it's going to give me a blob of string data, and it's going to print the new line characters as part of that blob. And so if I run that up, I get the exact same thing. And the difference here is I'm not actually iterating through a list. What I'm doing is I'm printing sort of character for character exactly what's in the string, and it just happens to contain or embed those new line characters. Great. Okay, so that's all well and good, but what we originally came here to talk about were unmanaged resources. And it turns out that these things, these static methods, they are using the unmanaged resources within the actual static method. So you don't have to deal with having an unmanaged resource, because this thing doesn't actually have state. It doesn't give you the state back, or the state of the StreamReader, the file handle. So you don't have to dispose of it. It's actually disposed by the static method that you're calling. Let's say that you did not want to do it that way, and you wanted to do it with a StreamReader yourself. And so let's think about sort of the reasons why you might want to do that. So if you are reading 3 terabytes of text data from a text file, these first 2 methods are not really what you want to do. And the reason is because immediately right out of the gate, what you're going to do is store 3 terabytes of text data into a local variable. And what that's going to do is it's going to blow up the RAM utilization of your console application, which is not necessarily great. This is going to be a humongous data structure that then you're going to be iterating over with this sort of boilerplate iterator. And so this is probably pretty optimized because Microsoft has been using this for quite some time. But you don't necessarily want to use something like this over a super huge data set. If anybody's ever used Hadoop or something like that, you don't just use like a standard iterator. There are ways of paging it to make things parallel. There are parallel versions of for each, but this is a very sort of naive way of dealing with large files. You wouldn't necessarily want to implement in production code. So the alternative is to use a StreamReader, and what this is doing is it is using the using statement, and what that does is it creates a new StreamReader, and this StreamReader only exists for the body of this using statement. And so as soon as you drop out of this using statement, suddenly the StreamReader named reader, it has its disposal implementation called. And so outside of this, on line 39, I no longer even have access to reader. Reader has been blown up. It isn't in the heap anymore. I don't have to deal with the overhead of carting the reader around as a file handle. Everything's kind of done for me. So what StreamReader does in terms of performance for large files is allows you to do the very, very familiar sort of line-by-line coding pattern for reading a file. So what this is doing is it's giving you a file handle exactly like Python's open method does, or Java's buffered reader. You can set a local variable inside of this scope to just be feed. And so what this is doing is it's pulling the next line from the StreamReader. As long as that thing is not a null or an end of file character, you're going to print that line. And then as soon as I read the end of file character, I'm going to jump out of this thing, and then I'm going to be done with my while loop. I'm going to be done with the using statement, and then reader is going to get disposed. So I don't have to call reader.dispose myself, and the reason is because the using statement is going to do that for me. If I tried to call reader.dispose, that would be entirely fine, but it's just going to get disposed twice, and that's a little bit of overhead that we don't necessarily have to spend. Going back to what we were saying a little bit ago, if I get rid of these using statements, That's all fine, except if something happens in this while loop and an exception gets thrown, I would never actually reach this line of code, reader.dispose, and so my reader would stay around for forever, and that is sort of the situation we're trying to get out of. This using syntax for kind of time boxing variable scope is very, very, very useful for things like connecting to a database and running store procedures. We're going to use this a lot in the persistence module. So this is something really, really useful to look at. And it also kind of solves a very concrete problem that people have had in .NET for a really long time. And that's with dealing with unmanaged resources. One of the largest kind of issues with WPF, which we're starting next week, is the fact that a lot of the UI elements or UI components are also unmanaged. And if you do not have something like a using statement, you can very quickly have a kind of dummy UI with a button and some text fields or whatever take a tremendous amount of RAM. And so it's something very, very important to start thinking about early, is using as little space as physically possible, even though we're using something that is widely considered to be a little bloated compared to something like C or C++. So that kind of does it for this overview. I hope it kind of illustrates how you can read a file. Writing a file is exactly the same, except it would be a StreamReader here. You could also do file write lines and pass it a string array. You can look at those methods. Everything that you can do with a read, you can also do with a write. So that should be pretty straightforward. There will be a component of one of the later programming assignments that requires you to do some file manipulation. So this is a good thing to sort of keep in your back pocket. And I'll upload this code to Canvas so that you can kind of get some practice with it. So thanks a lot, and please let me know if you have any questions. Happy to help out, and I will see you next time.